Okay, state one condition that must be satisfied for the Bernoulli equation to be valid, right? There's a bunch of things here, right? Remember, though, that the main thing is that the flow has to be laminar. Okay, laminar means not turbulent, right? Not turbulent or laminar flow, right? That the particles all continue and follow each other like that, right? They're not swirling around. That's the main thing. Another thing that, of course, that has to be true is that it has to be this density can't change, right? So that means that it can't be a compressible fluid, right? Now, even though we do this with air, which is highly compressible, we just pretend it's not compressible, right? Okay, there we go, right? Um, and then the other thing is that the viscosity has to be fairly negligible, right? Because if there is viscosity, it's going to lose energy. Remember that this is conservation of energy, basically, right? And so if your energy is not conserved, then it's just not going to work, right? Okay, but you have to just state one. You don't even have to explain it, right? So I've given you so much more here than you need. Okay, so then we got this pipe, and the pipe has a constant diameter, right? Okay, that's the key here, right? So if it's constant diameter, it has a constant right, area, right? Right, because the area wouldn't change if the diameter doesn't change, right? So why is the speed of the gasoline the same at x as it is at y? Well, it can't be compressed, right? And remember that the continuity expression says that what A1V1 equals A2V2, right? So if it can't compress, if the density can't change, and the area stays constant, then don't, and these guys are equal, then, right? Okay, so it's an outline. I don't know how much, you only have that much space, right? So I don't know how much of an argument you want to make, right? And then it says calculate the pressure difference between x and y. Well, take a look at this expression here, right? The v isn't going to change, right? So we're going to set up a thing possibly that's 1/2 rho v 1 squared plus rho g z1, right? Plus pressure 1 equals 1/2 rho v2 squared, right? Complicated formula, right? Plus rho g z2 plus p2, right? Okay. And what they're asking us is what's the pressure difference between x and y, right? So that's going to be what, p2 minus p1 or something like that, right? Well, the velocities are the same, right? This velocity and that velocity are the same, so these terms will be the same on both sides. They're not zero, but they're the same, so we can cross them off, right? And so basically what this is going to boil down to is it's going to be rho g, what, z2 minus rho g z1. Well, z2 minus z1 is just 1.2 meters, right? So long story short, the only thing that's going to make these different is the hydrostatic pressure. The change in pressure will be the rho g change in z, which is our vertical distance, right? So rho is this, g is 9.81, and the change in z is that. Okay, let's take a look at what's our next question here. Okay, so the diameter at y is made smaller than that at x. So this thing is now made so that it's like that, right? Okay, so now it's going to be going, we'll talk about what happens to the velocity here, right? If you make that smaller, what happens to the velocity? Velocity, okay? So what happens to the velocity? Answer that question. If you make this area smaller, what happens to the velocity? And if you make that velocity faster, right, what happens to the pressure due to the Bernoulli principle, right? So what happens to v at y, right? What happens to this velocity there? What does the Bernoulli effect have to say about whatever happens to that velocity, right? Does it increase or decrease if the velocity increases or decreases, right? So apply the Bernoulli, right? And then talk about why that would affect the pressure difference, right? Now remember that this pressure is less pressure already, and this is more pressure. Okay, and so this is somewhat subtle, right? If whatever this effect is decreases this pressure, then it would make this pressure difference bigger, and if it increases this pressure, then it would make the pressure difference smaller, depending on how big it is, right? Okay, so anyway, think about that, right? Okay, that's what's going on here.